Hello, this is the first of two videos that we're going to be talking about basic concepts of probability. So the very first thing that we want to talk about are some definitions. The first definition is for an event. So this is any collection of results or outcomes of a procedure. A simple event is an outcome or an event that cannot be further broken down into simpler components. And we'll look at some examples of these in just a moment. A sample space is all the possible simple events. That is, the sample space consists of all outcomes that cannot be broken down any further. Some notation, we'll always use a capital P to denote a probability. Capital letters like A, B, and C will be for specific events. So this notation with a P with an A inside parentheses means the probability of some event A occurring. And it's okay to write a capital P and then write words in here as well. That's totally acceptable. So we could have the probability of a girl. So that's totally fine to use that as notation as well. So here in our first example, we're going to let B represent the birth of a boy and G represent the birth of a girl. And we're going to, in here, list an example of an event. So an example of an event for, in this first row, the gray row, just for a single birth. And so an example of an event of a single birth would be one girl. And this is a simple event. This can't be broken down any further. And so the sample space, if you're just talking about a single birth, only has two things in it. Either the child is going to be a boy or the child is going to be a girl. And so we just have those two events, simple events, in the sample space. In the white boxes, we're going to give an example of three births. And so an example of an event would be two boys and one girl. So this is just an example of some event that could possibly happen in three births. This can be broken down though, so this is not a simple event. So we could break these down in simple events. And so the first child is a boy, second child is a boy, third child is a girl. So this is a simple event of this two boy and one girl event. There are other possibilities. So the firstborn could be a boy, secondborn a girl, and the thirdborn a boy. Or we could have the firstborn be a girl and the second and the third be boys. So these are simple events. So in general, all of the different possibilities for births. So we could have all three children be boys, and then we could have the three possibilities for two boys. So boy, boy, girl, boy, girl, boy, and girl, boy, boy. Now move on to having two girls and one boy. So boy, girl, girl, and then girl, boy, girl. The next one would be girl, girl, boy. And then there's one more, and that's if they're all girls. So this is the sample space. This is all of the different possibilities in the birth of three children. So there is a way to make a diagram. So I started off with all boys, then I did boy, boy, girl, and then see I'm moving girl back to the front. And then I went from two boys to one boy and listed all of those, and then I went to the last one, which is no boys. So that was my method for going through it, but you can also do a diagram. So the first child is either going to be a boy or a girl. If the first child is a boy, the second child could either be a boy or a girl. And also, if the firstborn was a girl, the secondborn could be a boy or a girl. So this would be the second birth. And then do it again for the third birth. So this option could have, let me move this down a little bit here. Otherwise it won't fit. So then from boy, boy, now third child could be either a boy or a girl. Here, same thing. Could have a boy or a girl. And again, the same thing. We could have a boy or a girl. And then the last one, also boy or a girl. And so then if you follow along these rows, you will get all of these different options. So boy, 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 girl, or boy, boy, girl, and then boy, girl, boy, and then boy, girl, girl. So that's those four. And then here there are four more. So girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. So that's another way for you to do it if that diagram is helpful for you. Just wanted to show you that that is an option. So next we have a few more definitions. The first one is a relative frequency approximation of a probability. So here you conduct an experiment or you observe a procedure and you count the number of times that event A actually occurs based on these actual results. So this is like sitting down with a die and rolling it a bunch of times and keeping a record of how many times you roll, for example, a 3. That's one of the examples that we'll take a look at. So that would be the relative frequency approximation of a probability. There's the classical approach to the probability. This requires that all of the outcomes are equally likely. So that means that all of them have the same chance of occurring. Assume that a given procedure has n different simple events and that each of those simple events has an equal chance of occurring. If event A can occur in s of these n ways, then the probability that event A will occur is the number of ways that A can occur, which is s, divided by the number of different simple events, which is n. The last one is subjective probabilities. This is not something that we will be computing ever, but it's nice to know that these exist. So again, notation, probability of A. And so this is the probability that event A is going to happen. And it's estimated by using knowledge of relevant circumstance. So again, this is not one that we will be looking at, but it's nice for you to know that that's out there. So our next example here, rolling a die and recording the number that is facing up. So our sample space would be the numbers 1, 2, 3, 4, 5, and 6. We can talk about this using the classical approach. So if we want to talk about the probability of rolling a 3, so you look at your sample space, and there's only one way to throw a 3, it's throwing a 3. And there's a total of 6 different outcomes in the sample space. So that would be 1/6. So the probability that you would roll a 3 is 1/6. And the relative approach, probability of rolling a 3. So here you would actually roll a die. Say 50 times. You would set how many times you were going to roll the die. You could roll it 50 times, you could roll it 100 times, you could roll it 25 times, but you're going to roll it a specified number of times and record how many 3s are rolled. And then you could compute your probability. So let's say three occurred 7 times, then probability of a 3 would be equal to 7 over 50. So the number of times the 3 occurred divided by the total number of times we rolled our die. A passenger dying in a plane crash, so this is subjective. And when you're computing a subjective probability, you would look at previous data. To estimate it. Next, we have the definition of the law of large numbers. This is talking about the relative frequency approach. So if you conduct an experiment a large number of times, then the relative frequency probability of some event will approach the actual probability. So if you roll a die a whole bunch of times, and as n gets really, really big, then the probability that you would get by conducting that experiment will approach the actual probability of 1/6. In our next example, a recent Harris Interactive survey of 1,010 adults in the U.S. showed that 202 of them smoke. Find the probability that a randomly selected adult is a smoker. So we want to find the probability of a smoker. And so on the top, we have the number of smokers divided by the number of people. This is the total number of people. So the number of smokers was 202, and the total number of people was 1,010. And so if you compute that on your calculator, you'll get 0.2. In our next example, we're going to use the table below, and assuming that 1 out of 1,000 subjects included in the table is randomly selected, find the probability that the selected subject got a positive test result. So we want the probability of a positive test result. And so this is going to be the number of positive test results divided by the total number of subjects. So in this notation, in case you're not aware, is just a shorthand notation for the word number. Okay, so we would be looking at all of the people in this column because those are the people that had a positive test result. So the number of positive test results we had was 44 plus 90 out of the total was 100. And so 44 plus 90 is 134. Divide that by 1,000 and we get 0.134. Okay, so that is it for this video. Let me know if you have any questions, and I hope you're having a great night. Thanks.